A sound wave in air travels a distance of 220 meters in a time of 0.7 seconds. State the equation linking speed, distance, and time. So you just have to say what it is, and it's distance divided by time is speed. You learn this in year 7, probably year 9. You learn it many, many times. Calculate the speed of sound wave in air. So let's look at that equation again. So we got distance, 220 meters, divided by time, 0.7. So we have 314.29, and I've rounded that to 2 decimal places, meters per second. Very easy. Just remember to look at the figures given to you in the question. Make sure you highlight them. Make sure you know what they belong to by looking at the units. So we have distance here, meters, time here in seconds, and make sure you plug them in the right way. So distance on top, then time underneath, and then work it out. Always double check or triple check on your calculator to make sure you have the right answer. That would get you 2 marks. Figure 2 shows water waves spreading out from a source. A student measures the wavelength of the waves. He uses a ruler to measure the distance from one crest to the next. So this is the crest and they're measuring a distance. Now that's going to be quite difficult. If you can imagine, the waves are going to vary a little bit. It's going to be tough to measure one wave only. Explain how to improve the student's method for measuring the wave. Rather than trying to measure one, why don't you measure a series of waves and then divide by the number of waves to work out an average wavelength. So measure the distance of many wave crests, divide by the number of wavelengths to find an average. So for example, you can measure this distance here and divide by 3 because you've got 3 wavelengths. Sound waves are longitudinal waves. Water waves are transverse waves. Describe the difference between longitudinal waves and transverse waves. Basically, there are 2 types of waves. One wave, the wave always travels forward, whether it's longitudinal or transverse. The difference is the effect that wave has on surrounding particles. So with longitudinal waves, as the wave travels forward, particles vibrate back and forth on the same direction as the wave. But transverse waves, as the wave travels forward, vibrations occur at 90 degrees to the direction of the wave, or oscillate at 90 degrees or at right angles. So you write this. Longitudinal waves, vibrations are parallel to the direction of wave travel, so they move in the same direction as the direction of wave travel. Transverse waves, vibrations occur at right angles to the direction of wave travel.